Hello guys, welcome to Basic Mechanics with NK StudySync. In this episode, I'll be introducing you guys to the course. What is mechanics? Mechanics is the physics of particles and rigid bodies at rest or in motion due to the action of forces. This then brings us to one core assumption we'll be using throughout our study of mechanics, the concept of a particle. So what is a particle? A particle is a body whom by virtue of its characteristic can be expressed as a geometric point. So let's take a graphical example. So assuming we have a point A and a point B, and we have, let's say, a car situated at point A, and the car experiences a force which moves it in the direction of point B, we can say that the whole car will be moved from point A to point B because we wouldn't see the tire being left behind, or the side mirrors being left behind, or the windshield on one door being left behind. So you can say that this whole car will be moved from point A to point B by that force. So then we can say that all sections of the car, or all sections of the body of the car, respond evenly to the action of the forces. So we take it. And then the car experiences a translational motion. So one may ask, what is a translational motion? So a translational motion is basically motion along a linear path. So let's say we have a stone, or let's make it a body or any round object moving along this path across a fixed distance, or moving along this path. So since this motion is linear, we say that the body experiences what? A translational motion. So that's what we refer to as translational motion. So this car being moved from point A to point B, since it moves across a fixed distance in a linear path, we say that this car experiences a translational motion. So then we can go ahead and take this. And then we say that the third characteristic of a particle is that it should be small in size. So although we can see that the car isn't small in size, but then if we consider how the car reacts to the force, we can just experience the car as a point, because if we also had a ball at point a huge ball, let's make a huge ball, experiencing the same force and moving the same distance from A to B. So let's give the car a mass, let's say 5 kilograms, and we give this ball a mass of 5 kilograms. And the force acting on this ball moves the ball from point A to point B. We can see that the car is similar to the ball, because in the end we have the car being positioned at point B by the force, and the ball also being positioned at point B by the force. So then we can just see that since we can express this ball as a tiny point moving from point A to point B, we can then express this car as a point moving from point A to point B. So it also meets the third requirement of a particle, where we said that it should be small in size. So we can also say that what a car can be expressed as a particle. This brings us to the concept of rigid bodies. So a rigid body, by definition, is a group of particles that have been held at a fixed distance from each other. So this is a rigid body. And then we can see that each of the particles are at a fixed distance from each other. So no matter what force is applied to this body, this distance doesn't change. So let's consider a lever with a pivot. If a force is applied at point A on the lever, we can see that point A moves in this downward direction, and point B, because of the pivot which is in the center of the lever, point B will move in the upward direction. So we can say that for a rigid body, when a force is applied at a particular point on that body, depending on which point it was applied, different points of the body would move in different directions. So if you observe, the more a force is being applied at A, the more the body will be moving in the downward direction, and the more point B will be moving in the upward direction. So if this continues, we can see that the rigid body, would experience a total rotational motion. So we can say for a rigid body, aside for experiencing a translational force or a translational motion, a rigid body can also experience what? A rotational motion. One thing we should keep in mind is that no matter the amount of force being applied on a rigid body, since we know that what the particles are at a fixed distance from each other, it then means that the body is not going to be dented, or the body is not going to break or fall apart. It's just going to be moved in a certain direction depending on where the force is being applied. So that's enough with the overview for today. So now let's look at the course content, or basically what we'll be treating in this course, basic mechanics. A course outline. So in this course, we'll be looking at the fundamental principles and concepts of Newtonian mechanics. That is Newton's law of motions, Newton's law of gravitation, and you name it. We'll also look at forces, which are vectors. So we'll look at vector analysis and various operations performed on vectors in analyzing how forces act. We'll also look at moments of a force. That is, we'll look at centroids and introduction to moments of inertia. We'll look at equilibrium analysis of particles and rigid bodies. That is the analysis of forces acting on a body at rest, so a stationary body. We'll look at analysis of structures. We can have trusses under that. We'll look at friction and selected simple machines like pulleys, levers, as stated in the previous example. We'll look at particle kinetic relationships. We'll look at motion, that is like the linear motion, curvilinear motion, and angular motion. And then we'll look at kinetics, that's force, mass, and acceleration. Thank you all for watching this video, and please do what to like and subscribe, and I hope to see you in the next video.